Lesson 2, we're looking at the area of right triangles. And to begin the lesson, we have an exploratory challenge where we're asked to use the shapes that are labeled with an X to predict the formula needed to calculate the area of a right triangle, and then explain our prediction. As an illustration of what would happen if you have the physical materials, there are two shapes here with an X, and then each group will need to cut these apart and then fit them together to prove that this right triangle and this right triangle added together make this rectangle. So if two right triangles added together equal the area of one rectangle, then the formula for the area of right triangles would have to be 1/2 times base times height, because base times height is how we find the area of a rectangle. And then the area of the given triangle, and it was 3 units by 2 units. So 3 times 2 is 6, and half of 6 is 3. The area of the given triangle would be 3 square inches. And remember, area is always in square units because it is what is filling the inside space. So we're talking about little squares. How many little squares would it fill the inside space? Next, we're asked to use the shapes that are labeled with a Y to determine if the formula we discovered in part 1 is correct. So the shapes that are labeled Y look like these two. First, there is a right triangle split into this rectangle. And so we would cut out this right triangle and take it and fit it into the same size rectangle, or in this case, this is a specialized rectangle, it is a square. 3 units on each side, so this is a square. And we would fit that piece over to prove whether or not our formula from part A is correct. And the formula from part A, remember, was 1/2 times base times height. And ultimately, our area formula, if we did it correctly in number 1, our area formula should match. And the formula again is area equals base equals 1/2 times base times height. The area of the given triangle, and that was, remember, a square that we started with. So our area then would be 1/2 times 3 times 3, which would be 4.5. And those were square inches. In the exercises, we're just going to calculate the area of each triangle using the formula 1/2 times base times height. So, in number 3, we have a base of 15 and a height of 8. Now, although they will give us other measurements, the only measurements that matter, remember, are the base and the height, where the height is perpendicular to the base, makes a right angle with the base. So then we would do 1/2 times 8 times 15, which then is 60 square feet. And remember, just like with a parallelogram or any other figure, when you're finding area, the area is in units squared. You do not put the squaring on the number, only on the units. Number 4 has some decimals in it. Formula is still the same. 1/2 times our base, which is 11 and 4/10, times our height, which is 17 and 7/10. There we go. And that is 189 hundredths square centimeters. And I want to point out that when you are doing the calculation, this is all multiplication. And remember, multiplication is commutative, which means we can multiply in any order. So if you put 17 and 7/10 first and then 11 and 4/10, it still would be the same answer. Number 5. Here we have a triangle that is turned on its side. But again, our formula is 1/2 times the base times the height. And the base and the height have to be perpendicular to each other. So the two numbers that we'd be using are the ones that create the right angle. So we're doing 1/2 times 8 times 6. And that will be 24 square inches. For some of you at this point, you may be finding that if you do 1/2 of the first number, 1/2 of 8 is 4, and then multiply, it's a lot easier than doing the fraction as a fraction. And in number 6, we have 1/2 times 8 2/3 meters times 5 3/5 meters, because those are the two sides that make the right angle. And that gives us 24 4/15 square meters after we've simplified our answer. In number 7, they did not give us the third side. But remember, we don't need the third side. We only need the two sides that form the right angle. So we have 1/2 times 21 4/10 times 32 7/10. And again, doesn't matter which one you call the base and which one you call the height. The two sides that you're using are the ones that make right angles with each other. And that gives us 349 89 hundredths square kilometers. In number 9, we have more of a real-world type problem. Mr. Jones told his students they each need 1/2 of a piece of paper. Calvin cut his piece of paper horizontally, that's a cross, and Matthew cut his paper diagonally. Which student has the larger area on their half piece of paper? And explain. Now notice there aren't any dimensions here at all, and that's on purpose. You don't have to find the area of each of these cuts in order to be able to compare them. Remember, the formula for area of a rectangle is base times height, where the base and the height are perpendicular to each other. And of course, in a rectangle, they are, so base times height. And then Calvin cut his paper in half, so the piece that is 1/2 of it would be 1/2 times base times height. And then Matthew also started with the same rectangle, base times height, and he cut it in half diagonally. which of course created for him two right triangles. And the formula for a right triangle is 1/2 times base times height. So we can see that both students have exactly the same area on their half of piece of paper. Next, Ben took 3 bathroom tiles to the store to be cut. The only direction he gave was that he needed the area of each tile to be half of the original size. If Ben wants each tile to be cut into 2 right triangles, did he provide the store with enough information? Well, when we look back at number 8, where we looked at a horizontal cut and then also a diagonal cut, we know that that's the same area, which is half of the original size. So Ben has not given enough information because it's very possible that the store could cut them horizontally, or for that matter, could even cut them vertically, because that would still be half as well. So, not enough information. And finally, in number 10, they give us the area of a triangle and its base, and they want us to write an equation that relates the area to the height and base, and then solve the equation. Very much like our last problem in lesson 1. So remember, the area of a triangle equals 1/2 times base times height. So we'll use that formula and substitute the information that we have. The area we have as 6 22/100. And remember, this will be 1/2 times base, which is 3 11/100 times the height, which is the part that we're looking for. So to solve this equation then, we need first of all to combine our like terms. And on the right side of our equation, we have 1/2 times 3 11/100. So we'll have to multiply those two together first before we try to divide to solve. So 1/2 times 3 11/100 is 1 555 thousandths, which we then would be multiplying times h. And now we can solve this equation by dividing by 1 555 thousandths on both sides. So we have 6 22/100 divided by, and remember I'm writing the division as a fraction basically. And then on the other side, when we divide by 1 555 thousandths, we'll end up with h. And our final answer then is 4 inches. The height is 4 inches. Notice when we work backwards that we no longer have square inches because we were actually dividing by the inches of its base.